Hello everybody and welcome. My name is Andrew and today we're going to be talking about 5 reasons how science proves that the earth is round. In early times, around 1000 AD and before then, many people thought that the earth was flat rather than round. They thought this because they did not realize how big the earth was and never traveled more than a few miles away from their homes, because they had necessities that they had to worry about more than traveling. This changed in 1492. This idea of a flat earth changed in 1492 when Columbus discovered America. It was then revolutionized again in 1522 when Magellan completed his circumnavigation of the earth. NOAA, or the National Oceanic and Atmospheric Administration, says that the Earth is an irregularly shaped ellipsoid. This means that the Earth is slightly fatter at the equator and thinner at the poles. The first reason how science proves that the Earth is round is the moon. The fact that the Earth has the moon helps show that the Earth is round. The famous Greek thinker and philosopher Aristotle observed during a lunar eclipse that the shadow casted on the moon was curved. And so a lunar eclipse is when the Earth is in between the sun and the moon, and the Earth then casts a shadow onto the moon. And this shadow is curved. So that led Aristotle to believe that the Earth was round and not flat, which for his time period, that was revolutionary thinking. The second reason is stars. So if we were on a flat Earth and you were to travel south of the equator, say you were going to Australia, if the Earth was flat, you would be able to see the North Star. But if you travel south of the equator, you will not be able to see the North Star because of the curve of the Earth. The third reason is because of gravity. So gravity on a flat Earth, so pretend this piece of cardboard that I have here is a flat Earth. Well, the center mass of this flat Earth or plane is at the very center. So if you were standing here at the edge, gravity would be pulling you sideways into the center of the Earth, towards the center of the Earth. This is not the case on a spherical Earth, though. A sphere center's mass is the very center of the sphere. So I have this ball here, and so the center mass of it, if it was like the Earth or another planet, would be the very center inside of it that we can't see. And so the pull of gravity will then pull downwards towards that center mass of the sphere. The fourth reason is seeing farther when higher up. On a flat Earth, no matter how high up one is, it would not make a difference in the distance you would be able to see. So for example, say this is a mountain, and you have a person standing here, and this is a mountain, and a person standing here. Well, they're going to be able to see the same amount of land and everything. Whereas on a round Earth, the higher up one goes, the farther one can see. This is true especially for mountains and hills. And so the higher you go up, the more you'll be able to see. So pretending this is our mountain again, and you have another person standing here, well, this person is going to be seeing less, and the person that's up here will be able to see more because they have a much larger vantage point. This is why during survival situations they say that you should climb a tree to take a look at your surroundings to formulate a plan. Another reason why seeing farther when higher up it proves that the Earth is round is for plane trips. On most flights, depending upon how high the plane is, you are actually able to see the curve of the Earth on the horizon. This is especially true for cross-Atlantic trips. In addition, pictures of the Earth have been taken from space which show that the Earth is round. So, I don't know whether or not you believe in whether some of the space stuff is faked or photoshopped, but it shows very clearly that the Earth is round and has produced many spectacular and beautiful pictures. The fifth and final reason is ships on the horizon. So on a flat Earth, if you were here where my thumb is, and this is a ship, you would see the ship from a far off distance. See? And it would just appear out of the horizon, quote unquote. But for a round Earth, you would seem to see the ship emerge from the sea. So basically what this is saying is, if you're here where my finger is, then the ship is coming and it's coming towards it. So if you've ever lived at a port or been to a port or seen a ship come in or come in contact with another ship while on a ship, say for a cruise or something, you'll see that from far away, so this is what happens. You see a little bit of it, and then as it gets closer to you, you see more. That's because of the curve of the Earth. All in all, I believe that I have given compelling evidence through the moon and the curved shadow that the Earth casts onto the moon during an eclipse, the stars, and how you're not able to see the North Star below the equator, and you're not able to see stars that you can see below the equator on the north side of the equator, and how gravity on a flat Earth pulls you sideways, whereas gravity on a spherical Earth pulls downward towards the center. And so that helps prove that Earth is round, and seeing farther when you're higher up, as well as ships on the horizon. Thank you, and have a good day.